Okay, so in the first video, I set up the IV bag, the tubing. We got it all primed and running. You saw the drips in the drip chamber. What I want to do now is the math involved in that. So we call it gravity infusions. We have to have a few different numbers. We're going to have the doctor's order. So the provider's going to order how fast to run the fluid. So, for instance, the doctor will want it to run at 100 milliliters per hour. That's how much fluid's going to go into the patient every hour. Well, that's all well and good if we have an infusion pump, because we can press the buttons on the pump and set it to go 100 and hit start, and we're good to go. But when doing gravity infusions, we have to do a little bit of math, and that's what we're going to work on now. So we can still take the same doctor's order, 100 milliliters per hour, but we're going to need some more information. We're going to need what's called the drop factor of the tubing. So on my picture here I drew, thinking about drips. The drip chamber is the portion of the tubing right below the spike that attaches to the bag of fluid. And that's where we're going to see the little drips. Now each tubing itself that comes in a package has its own drop factor. So that's what I wrote down here. The drop factor is listed on the package. And I'm going to show you what I mean here. So here is a package of tubing. It's all one piece inside here. You saw that in the other video. But on every package of every tubing made for IVs, there's something called the drop factor. So this particular tubing, the drop factor is 10. Every milliliter of space holds 10 drops of fluid in this size of tubing. So you'll see different ones. There might be 15 drops per ml. There might be 60 drops per ml. You always have to check your package. So it's whatever package you're using, that's what counts. We're going to look at a few math problems that throw that number in there. All right, so let's look at the first one. Now in your guide, you have a couple of questions, and they're at the beginning before the PowerPoints. So if you want to flip to those pages, there's 4 questions. Infusions using the drop factor or gravity infusions. So when we're testing you on these math problems, we will specifically say gravity infusion versus on an IV pump, or we call the IV pumps EIDs, electronic infusion devices. So the math questions on a test will be specific to one or the other. All right, so the first question that was in your book, the question read that you have a patient needs an infusion of D5W, which if you were listening to the lecture material and reading up on the IV fluids, that's dextrose 5% in water. And the doctor wanted it to run at 100 milliliters per hour. The tubing drop factor on the package reads 15 drops per ml. What is the drip rate? Okay, so we've got 100 mLs per hour. We've got drops per ml. And we actually, when we're doing our math, our end result needs to be drops over minute. Now, I'm briefly going to mention that in the other video when I'm setting up the infusion itself. But I want you to think about this, drops per minute. So in my little, I'm going to draw a drip chamber again. It's going to be awesome. Okay. It's filled with fluid down the tube. And the drops are coming out of the IV bag into the drip chamber. And as it's dripping, I have to count them. So that's what this end point's going to be. If I'm counting the correct amount of drops, it's going to show me that I'm running it at this infusion rate the doctor ordered. So I can't stand here all day counting for a whole hour. If I did, I'd be counting like 4,000 drops per hour. I have other things to do. So we actually calculate the drops that fall in 1 minute. So that's where we get the drops per minute. So I'm going to set up my problem with that as my end unit of measurement. So I'm just going to leave it written there. Now with this math, little different than medication math is that what we care about in these problems is volume and time. So I'm going to write volume over time. So in this particular problem, doctor's order gives us a volume and a time already, yay. So 100 milliliters per hour. So I'm going to put 100 mLs in 1 hour. All right. So far, my units of measurement are milliliters over hour. My end units are drops over minute. So I'm nowhere near finished this problem, right? I need to get the drops in there. I need to get the minutes in there. So I'm going to get my drops in there by using the drop factor of this tubing was 15 drops in a milliliter. Now, in order to end with drops and no mLs left, to cancel out the mLs, they have to be on the opposite right side of the equation. So I'm going to have my 15 drops on the top per ml, which is great because I can now cancel ml. Now I got drops on top of the equation. I've got an hour on the bottom. So I'm going to use my conversion factor. Yes, I can just go ahead and convert this right now, but I'm going to do it the long way so that when you're writing out these problems, you put in all the steps. So I'm going to say my conversion factor here is hours to minutes. So every 1 hour, turn that into a line, has 60 minutes. Now I can cancel out hour on top with hour on bottom. I'm left with drops on top, minutes on bottom. So I know this is set up correctly. So I just need to multiply across and divide. Okay? And I'll theoretically give you a minute, but why don't you pause the video to do the math, and then I'll write down what the answer is. Okay, I'm going to write it down, so if you didn't do it yet, pause it. All right, so it's 25 drops per minute. So that literally means I'm going to stand in front of this drip chamber with my second hand on my watch for a minute, and I'm going to count that 25 drops fell in that minute. If 30 or 40 drops fall, it's going too fast. That means I'm going to adjust the roller clamp, slow it down a little. If 12 drops are falling in a minute, it's going too slow. As soon as I get it to 25 drops a minute, that means I'm infusing it at 100 milliliters per hour. All right. So in reality, when you start working, hopefully our world is back to normal. You will be using electronic infusion devices most of the time. But you might work in an emergency room or some other place in home care where we still are doing this gravity infusion math. Currently, they are using this a lot because we don't have enough IV pumps in the world. So this is an important way to know that we're not giving somebody the fluid too fast, because if the provider orders 100 milliliters per hour, that's what has to be given. All right. So our next problem had nafcillin, 1 gram, and 75 milliliters of dextrose in water, infuse over 40 minutes. Tubing drop factor was 60 drops per ml. All right, so going back to what I actually need out of that, it's volume, time, and I know I'm going to end with drops per minute. Okay, so volume and time, my volume is 75 ml. And it gives me the time in minutes, which I'm very excited about, 40 minutes. Okay, so I've got mLs, I've got minutes, so I got part of this ending unit of measurement I need. Then I need to bring in my drop factor of the tubing. Okay, so I've got 60 drops per ml. That allows me to cancel the mLs out. I'm left with drop on top, minute on bottom. That is what I want, that's what I need. I'm going to multiply across and divide. So I'm going to let you pause, do the math, and then restart. Okay. So I'm about to write the answer. I encourage you to do it yourself, so pause it and do it. So what we're going to get when we do the math is 112.5. Let's think about that. Can I do 112.5 drops per minute? Okay, the answer is no because of this. I can see a full drop of liquid. I can't see a half drop. I'm not that good. So I am going to have to round this. So your rounding rules, 5 or greater, we're going to round up. 4 or below, we're going to round down. So we're going to actually do this at 113 drops per minute, which is pretty fast when you're looking at it on your watch with the second hand. Okay. So when we're doing this type of math with gravity infusion, it's going to be a whole number. Just remember that. We can't see half a drop. We can only see a whole drop of fluid. All right, we'll do a couple more. Okay, we got our next one was potassium, 20 milliequivalents in 150 mLs of D5W infused over 2 hours. Drop factor was 15 drops per ml. Okay, so volume over time. So, and I want to point that out because sometimes people start pulling these numbers that we don't need into this problem. This is a problem about how fast do we want the fluid to run in the patient. We're not worried about the dose of the medication in these math calculations. Okay, so volume here is 150 mLs. Oops, that's not right. 150 ml. And over 2 hours. All right, we're going to end with drops per minute. And we're going to go ahead and pull in our drop factor here. 15 drops per ml. We can get rid of our ml. We can then, sorry, I just had to throw a pillow at a dog. Riley, stop it. Stop. You're bugging me. Okay. So we got rid of our mLs. We have drops over hour. Again, I'm going to use my conversion factor, 1 hour, 60 minutes. So I can cancel out the hours. I got left drops on top, minute on bottom. That's what I want. Multiply across and divide. So pause the video and write out the math. And it's going to be, when I do my first calculation, 18.75. I got to round it. So it's going to be, wow, that's a terrible writing. Okay, 19 drops per minute. So that's going to be me standing there counting the drops in 1 minute's time. All right, and then our last one, doctor ordered 500 mLs of dextrose and water over 8 hours. So our volume over time was 500 ml, 8 hours. We want to end with drops per minute. And I've got a drop factor here of 10 drops per ml. Cancel my mLs, and I got to do my time conversion. So 1 hour, 60 minutes, hour, multiply across and divide. So pause your video, do your math, and then I'm going to end up with 10 drops per minute. Again, remember, they always have to be a whole number. And the answer to the question that people are asking is yes, I could go ahead like with this 2 hours. I know 2 hours is 120 minutes, right? So I could put 150 ml over 120 minutes and save this step. But I like to use the conversion factor. Your math will get more complicated as you go through the program. So having each fraction set up in a line makes it so much easier to do the math. All right, so we'll have more practice questions on Blackboard, but hopefully that'll get you started and you'll have a, sort of a general understanding of this IV math. All right.